Welcome to my classroom. This video talks about a game. Prepare a piece of paper and some coins of same size. You can play the game with a kid, and the video is for all levels. It is a game for two players. Player A and Player B take turns to place a coin inside a rectangular paper at anywhere they wish, but not overlapping with other coins, until there is not enough space for a further coin. The player placing the last coin wins the game. Player A goes first. Who will win the game and how to win? It is good to play the game actually, but if you could not find someone to play with you, treat the game as a mental game and think about the winning strategies. Still, it could be a good fun. Pause and enjoy. To win the game, it is important to determine where to place the first coin. First, let us consider the coin. To make things easy, let us use a point to represent the location of a coin so that we only need to think about a point instead of a circle. Which point should be used? The obvious choice is the center of the coin. Now, the coin is placed on a rectangular paper. According to our experience in the video of a cut on a cake, we noticed that the point of intersection of two diagonals of a rectangle, let me call it as the center of paper. This point has a good feature that any line passing through the center divides the paper into two equal parts. Can we make use of this center to find out the winning strategy? The answer is positive. Let me denote the center of the paper by O, and P is a point inside the rectangle other than O. Then OP determines a straight line. Consider the refractive image of P with respect to O and denote it by P prime. Here, P prime lies on the line formed by O and P, and the distance between O and P prime is equal to the distance between O and P. Thus, if P lies inside the rectangle, then show it as P prime. Okay, I suppose you may get the idea of the winner and also the winning strategy, right? Player A places the first coin at the center O of the paper. Then it goes to Player B's turn. Player B places a coin at a point other than O and denote it by B1. The turn goes back to Player A. Player A places a coin at the refractive image of B1. I denote this point as A1, as it is the first round after the coin at center is placed. Similarly, Player B chooses B2, and Player A takes the refractive image as A2. Then, wherever Player B can find a space to place a coin, according to refractive symmetry, Player A can also find a space to place another coin. In this way, Player A is the last one to place the coin inside the paper. Thus, Player A wins the game. The game is done. I put two follow-up questions here as the remarks. First, if the size of the paper and the coins are known, can you find the maximum number of the coins used for the game? I think it is an easy question. Second, how about finding the minimum numbers of coins used for the game? You may assign values for the dimensions of the paper and the coins for your exploration. Enjoy!